Question number 11. F equal MA. M is 50 kilogram. F is 400 Newton. So your A is force divided by M. 400 divided by 50 equal 8 meter per second square. It's A. Number 12. The table lists the coefficient of kinetic friction for 4 materials sliding over steel. A 10 kilogram block of each of the material in the table is pulled horizontally across the steel floor at constant velocity. F net is 0. Which block will require the smallest applied force to keep moving at constant velocity? So we know when you have a block, you have gravitational force, you have normal force. And what's more importantly here is your applied force and the frictional force. Since your F net is 0, that means your applied force and the frictional force, they're equal to each other. So that means the more frictional force you will need, more applied force. Okay? So we know friction is coefficient times normal force. And they say all blocks have 10 kilogram, right? So the normal force will be the same. That means the higher coefficient of friction, the higher the friction. If you want to use the smallest applied force, that means you need the smallest friction. The smallest friction will be copper because it has the smallest kinetic friction coefficient, which is C. Number 13. In the graph shown below, the acceleration of an object is plotted against unbalanced force. What is the object's mass? Basically, you can pick any of those points. You can pick this point, or this point. So we know mass is force over acceleration. You can pick 3 Newton. I'm picking this point. 3 Newton over 6 meter per second square, which is half or 0.5 kilogram. C. Number 14. So the diagram represents a car resting on a hill. Which vector best represents the weight? Weight is gravitational force. It's always pointing straight down. So it's B. Number 15. In the diagram, box M is on a frictionless table with force 1 and 2. If the magnitude of F is greater than F2, so F1 is bigger than F2, that means, first of all, there is unbalanced force, right? Unbalanced force means there will be acceleration. At what direction? The direction of the greater force. So your answer is C, accelerating in the direction of F1. Number 16. The diagram shown represents a force acting at point P. Which pair of concurrent forces will produce equilibrium when added to the force acting at point P. Okay, so basically, this force is our hypotenuse. Okay? Yeah, I can spell that. And then, which two vector are its x and y component? Or could be its x and y component. Okay, here it says we need to find which force A, B, C, D or their resultant force will produce equilibrium. Remember we learned equilibrium last semester that if this force is applied from P, the equilibrium force should be the same magnitude but opposite direction, right? So basically we're trying to find A, B, C, D, which one represent this blue force, okay? Which is pretty obvious. The one that represents the blue force is D, okay? Number 17, the graph pictured shows the relationship between the weight and mass of a series of objects. The slope of the graph represents so we have to figure out how we find the slope, right? If you remember your math, the slope, which is m, equal delta y over delta x. Basically, here our y is weight, our x is mass. Remember, weight is mass times gravity. So gravity is weight divided by mass. That's why the slope is equal to the gravity, which is also the acceleration due to the gravity. Okay? Number 18. Each diagram shows a different block being pushed by a force across the surface at a constant velocity. Again, that force is equal to 0. Always pay attention to the acceleration and velocity. In which two diagrams is the force of friction the same? So, since the net force is 0, that means applied force should be the same as frictional force, right? So which two has the same applied force? A and D. Your answer is C. Number 19. A box decelerates as it moves to the right along a horizontal surface, as shown in the diagram. Which vector best represents the force of friction on the blocks? This is direction of the motion. And this is the opposite direction of the motion, which is the frictional force. Number 20, the weight of an apple is closest to okay. A is 0.01 Newton, B is 1 Newton, C is 100 Newton, and D is 10,000 Newton. If you convert that to kilogram, Obviously, A is wrong, D is wrong. It's between B and C. B is about 0.1 kilogram, which is 100 gram. And C is about 10 kilogram, which is 10,000 gram. Common sense. So the answer is B.